Starting a new chapter today, and our final chapter in this course of pre-calculus, okay, will be a study of trigonometry. And there's two ways you can attack trigonometry, okay? You can do it as it's done in chapter 5. You can do it as it's done in chapter 6. I happen to like the way it's done in chapter 6 a little bit better. I think it's easier, and if you're not very well practiced in trig, this should go much easier for you. So today we're going to primarily just talk about angles in circles, areas, circumference, arc length in circles, and we'll also talk about radian measure a bit. So let's get started. All right, when you have an angle, this angle that is shown here can be named in a lot of different ways. It can be called simply angle B, the vertex of the angle, the corner of the angle, if you simply use that letter B, okay? By the way, it's a 60-degree angle measure. If there was no 60 degrees in here, and if say there was just a number 1 in there, you could call it angle 1, okay? Different ways you can write with 3 letters. You can write it as angle ABC or angle CBA. The B, the vertex, the corner point, has got to be in the middle of the 3 letters if you're going to do that. Now, the initial side, we're going to think about angles as always starting on the positive x-axis, which goes to the right, correct? So BA, ray BA is on the positive x-axis. If it goes counterclockwise, if it's counterclockwise from the initial side to the terminal side where it ends, terminal means stopping, okay? This is a positive 60-degree angle. It goes counterclockwise to be positive. If it would go in a negative direction, if it would go clockwise, then it would be a negative angle, okay? So we're going to measure angles from the x-axis, positive x-axis. Going counterclockwise, it's a positive angle, and clockwise, it is a negative angle. I'll give you some more practice on that. Okay, so here you can see a couple of angles. I have a negative 240 degrees in green. Starts at the positive x-axis and goes clockwise. Now, it runs through about 2.5 quadrants, all right? There's 360 degrees in a revolution, right? So each quadrant would be a rotation of 90 degrees. So there's 90, there's a total of 180. 60 more degrees would make a negative 240 degrees, all right? What's left over for the red angle? You could subtract that from 360. The red angle is 120, starting here, coming here. This is a negative angle because it's going clockwise. This is a positive angle because it's going counterclockwise, okay? The red angle and the green angle are called coterminal, all right? Which means that they start and stop at the same rays. They both started here and they both stopped there. So they're called coterminal, okay? Could you name another positive angle coterminal with 120? Is there another angle that starts here and stops here? Okay, well, the way it stands right now, the red one is the only one. But what would happen if you start here, and if you went the whole way around, make a revolution of 360, then did another 120, right? Wouldn't it still start here, come the whole way around, and then stop there, and it would stop there? So 360 plus 120 is 480. 480 and 120 would be called coterminal positive angles, positive degree angles, okay? Can you name another negative angle with the 120? Well, we know 120 is coterminal with the negative 240. How could I get another negative angle? Do the same thing. Instead of starting here and stopping here, make a complete revolution, then go 240 more, and you will have a negative angle that started here and stopped there. So negative 240 comes here, but make a revolution of 360, then do 240, and isn't that a negative 600? Okay, negative 600. All right. Let's go back here. The red coterminal, I just want to double check that one. The red coterminal was 120. What's another positive angle coterminal with that? You could take a 360 plus the 120 and get 480. Right. Okay, let's talk a little bit about degree measure. Okay, now, we have all been schooled in degrees. There's 360 degrees in one revolution. Okay? Where did that come from? I mean, what is the rationale for 360? If they want to do anything, why not put a lot of zeros in it? Say it's 100 or 1,000. You know, if you're going to make up a number, why do it to 360? The interesting thing is most of the world, as you probably know, works in the metric system. We don't. We work in English, feet, miles, inches, Fahrenheit instead of centigrade, okay? But most of the world works in the metric system, and most mathematicians use radian measure. Now, what is radian measure? Just as if you think of a 120-degree angle, the red one, I don't care how big you make this picture, I don't care how small you make that picture, it's always going to be 120 degrees. If you blow it up or scale it down, it's always going to be 120 degrees. If you take a unit circle, unit means one. A unit circle, 1 inch circle with a radius of 1 inch. Or how about a circle with a radius of 1 centimeter? Or a radius of 1 foot? Or a radius of 1 mile? Okay? I don't care. You draw any circle with a radius of 1 something. The circumference is always 2 pi r. Circumference equals 2 pi r. You may want to remember that. While we're at it, area of a circle is pi r squared. Okay, so if you have a unit circle, a radius of 1 inch, 1 centimeter, 1 kilometer, 1 mile, I don't care. The circumference will always be simply 2 pi, right? No matter what, for all those circles. Well, then why not use 2 pi? Because it's universal, it applies to everything. And to me, that makes so much sense. The total measure of the angles, if you do 1 revolution, is 2 pi. The other beautiful thing about radian measure, you don't have that goofy little degree symbol hanging on the end. These are just numbers. 2 pi is just a number. 2 times 3.14 is 6.28, okay? Radian measure does not need any numbers, and in calculus, that is of supreme importance. All right, so 360 degrees, 1 revolution is 2 pi radians, all right? Or you can divide both sides by 2, and 180 degrees is pi radians. I'm going to mark that down. 180 degrees is 2 pi. We will need that. Suppose you want to change 45 degrees and 60 degrees to radians. Okay, if you have 45 degrees, you want to get rid of degrees. Degrees will go on the bottom. So 180 degrees goes on the bottom, and senior moment. 360 is 2 pi radians. 180 is just pi radians. Sheesh. All right. Now the degrees cancel. You see that? And 45 into 180 goes 4 times. So 45 degrees is pi over 4 radians. A lot of mathematicians let the answer like that. You can take 3.14 and divide it by 4 if you like. I don't care. But that's changing degrees to radians. How about 60 degrees? Do the same thing. 60 degrees times pi over 180. The degrees are going to cancel. 60 into 180 is 3. Pi over 3 degrees. How about pi over 6? We want to change it back to degrees. Pi over 6 is a radian measure. Pi over 6 is a radian measure. So we want to get degrees. We'll put 180 on the top, the pi on the bottom. You see the pi's cancel. 6 into 180 is 30. Pi over 6, radian measure. Pi over 6 is a 30-degree angle. How about pi over 5? Pi over 5, do the same thing. Pi on the bottom, 180 on the top. They cancel. 5 into 180 goes 36 times. Okay? For the scope of our course, we're going to be in chapter 6 for only like 4 sections. Not that much time. I have a feeling most of you will be more comfortable working with degrees. So there's going to probably be a lot of this going on. Make sure you understand this, okay, so that you can comfortably change radians to degrees, okay? You can comfortably change radians to degrees because you're going to be doing it quite a bit. All right, I just want to make sure everybody's comfortable with this positive and negative angle stuff, okay? You always start on the positive x-axis, which is here, right? Okay, if you go counterclockwise, it's a positive angle. If you go clockwise, it's a negative. Can you guess at the angle size? Like, for instance, here, we start here, there's 90. When you do one quadrant, that's 90, and that looks like it's a little bit more than half, right? Half of 90 is 45, plus 90 would be 135. That looks like it's more than half. I'm going to guess like 150, maybe, okay? How about down here? That looks like it's perfectly halfway. So we have 90 plus 90 is 180, plus half of 90 would be 45. That would be a positive 225. Can you guess these? Look at this one. This isn't quite halfway. So we have a 90, a 90, a 90. That's 270. And add 30 more because we don't want to go halfway. Maybe that would be like a 300, positive 300-degree angle. How about these red ones? You see, they all start at the positive x-axis, but they're going backwards. They're going clockwise. So we know that these are all negatives. You see, this one is not even a whole quadrant. If it was, it would be a negative 90. And it's a little bit over half, so I'd call it at least a negative 60, right? Look at this one. 1, 2, 3 quadrants would be a negative 270. It's not quite half. So if we'd add 30 more on, negative 300, as long as you make it less than half, what would half be? 90, 180, 270 plus 45 would be a negative 315. You got to make it less than that because you can see it's less than half of a quadrant. Here, this one looks perfectly at halfway, a negative 90. This was a negative 300, we said. Negative 90 and half of that would be 45. On to negative 90 would be a negative 135. Okay. Little practice on comprehending angles. All right, let's talk about some coterminal angles. If you have a 70-degree angle, all right, let's draw it. This is a 70-degree angle, okay? Find any angle whatsoever coterminal. I'd probably do a negative. Come this way, because it's so easy. You simply subtract 70 off of 360, right? Which would be a negative 290, right? If you wanted another positive angle, you'd have to go one whole revolution and then do the 70, which would be 430, I think, if my brain is working, okay? Find a positive and a negative angle coterminal with pi over 6. We just did pi over 6, but let's do it again. Pi over 6, we're going to change it to degrees. Okay, so we want to get degrees, put them on the top, pi on the bottom. The pi's go 6 into 180 is 30. So we're talking about, we have a 30-degree angle, okay? Hopefully you can see that. So find a positive and a negative angle, coterminal. Well, a positive angle, we'd have to make one whole revolution and add the 30, which would be 390. The negative angle is simply going clockwise, except for the 30, so subtract 30 off of 360, and it would be a negative 330. Okay? Find an angle between 0 and 360 coterminal with 1290. Holy smokes. 1290. 1290 is a lot of revolutions. See if we can do it. We're going to start here. If you make one revolution, you're at 360. If you make another one, you're at 720. If you make another one, you're at 1080, I think. Let me double check that. 720, I'm losing it. 720 plus 360 is 1080, right. Now, you don't want to go another complete, so if you subtract that from 1290, we have 210. So in other words, 1290. 1290 is one revolution to 360, 720, 1080, and then 210. Here is, down here is, we have 3 revolutions plus 210 will give us 1290. Okay? Right? So how can I find an angle between 0 and 360 coterminal with that? Well, what is just that? Didn't we say it was 210? Okay? So 210 degrees should be coterminal with 1290. Just what we do is get rid of, and another way to do it is start with 1290 and just keep subtracting 1290 and keep subtracting 360 until you can't go any longer. And what do you get? 210. Okay? Coterminal angles. All right, now the bulk of what we do in this first section will be, will be problems like this. Okay? Problems like this. You're going to need what is up here. All right. I want to find the arc length of AB, and I want to find the area of that sector. A sector is like a piece of pie, okay, the gold or the brown region. All right, now we know if we use C equals 2 pi r, we're going to find the total circumference of the circle. We don't want the total, we only want the portion that goes over the 120. I think a real easy way to do these problems is with proportions. You always have something little and you have something big. Okay, for instance, I want the measure of that arc. I don't know what that is. That's the little arc, would be to the whole distance around, which is 2 pi r. Is that not 8 pi? So the little arc to the whole big arc is x is to 8 pi as, now, what else do I know? I know the little angle is 120 to the whole angle of revolution. Is that not 360? Yeah? Okay, and you can simply cross multiply and solve the problem. This reduces to 1/3. So when I cross multiply, if it's 1/3, I get 3x is 8 pi, and divide 8 divided by 3 is 2 2/3, so it's 2.67 pi. 2.67 pi should be the length of that arc. Okay? It's 1/3 of the whole way around. Now, what about the area of the gold sector? Do the same thing. Little to big. This little area, I don't know what it is. How about the whole area? The whole area, is it not 16 pi, pi r squared? And then once again, the 120 to 360 is 1/3. And cross multiply and solve. You get 3x is 16 pi, or you're going to get x is 5.33 pi. You can either let pi in your answer, or you can multiply 5.33 times 3.14. I don't care. Okay? I think this is probably the easiest way to do the problems. There's a lot of different ways I could show you how to do these. All right, how about this one? If the radius is 4, the length of the arc is 11, find the measure of the angle. Okay, so I'm going to do little to big again. If the radius is 4, what can I find that's little? Well, S is 11 is the little arc. So I know the little arc is 11. What is the big arc? The whole way around. The whole way around, isn't it 8 pi? Right? So the little arc to the whole way around the big arc is 11 to 8 pi. Now we want to measure the little angle, x. I don't know what the little angle is, but I know what the big angle is, right? And then you simply cross multiply, okay? I'm not going to bother walking you through the cross multiplying. I think everybody knows how to do that. Let's do the second one. Radius is still 4. How about the area of the sector is 20 square centimeters? All right, let's do it again. Little to big. So the area of the little sector is 20. What is the area of the big? Isn't it pi r squared? Isn't it 16 pi? Yeah. And now let's do something else. We've got to get something else little to big. We want to find the angle. So the angle I don't know, once again, x over 360. How about the last one? We want to find the radius. Okay. Do little to big again. All right, so what can I do little? S. The length of this arc is 12. Okay. What is the length of the whole arc? The whole distance around is, I don't know. The whole way around is the circumference, and I don't know what the radius is. So isn't that 2 pi r? Now take a second and think about that. Okay, we're doing little to big. The little arc length is 12, and the length the whole way around, I don't have the radius. I can't do anything but write 2 pi r. Okay, so let's do little to big here. I know the angle is 120 over 360, little to big. And you can cross multiply and solve for r. Okay, just for kicks, let's do that one. That might be a little exciting. 12 times 360 is 4320 is equal to 2 pi r times 120 is 240 pi r, right? So now, to solve this equation, I want to take 4320 divided by 240 pi. So I'll use parentheses and put 240 times pi. And I get that the radius is 5.73 centimeters. Okay? Using what we have up here and doing a proportion of little to big, I think is the best way to do these problems. All right, let's talk about this one. We have a circle with a major sector, a minor circle, or minor sector is smaller. The radius of the circle is 5 centimeters. The sector angle is 20. Find the green area. Do little to big. Okay, I know the sector angle right in here is 20 degrees. So the little angle is 20. What is the big angle? The whole way around, 360. The radius is 5 centimeters. I want to find the green area. I want to find this little area. Okay, I don't know what that is. That's x. How about the area of the whole thing? The area of the whole circle. Isn't the area of the whole circle pi r squared? Pi r squared, 25 pi. Yeah? Cross multiply, solve for x. You will find the little green area. Okay? Once you know the little green area, how would you find the yellow area? Subtract the little green area off the total, 25 pi, right? Okay, let's do the last part of the problem down there. If the length of the yellow arc is 150 centimeters, okay, from here, the whole way around to here is 150, okay? And the green angle is pi over 10. Whoa, that's a radian measure. Maybe we want to change that right away. Pi over 10 is radians. We want to get degrees. The pi's go away. 180 divided by 10 is 18. All right, so the angle is an 18-degree angle. We want to find the radius of the circle. All right, now you're going to have to be careful with this one. Little to big. All right, we know the little angle. Okay, the little angle is 18 degrees. To the whole thing is 360 degrees. Okay, now we're trying to find the radius of the circle. Okay, so the length of the yellow arc is 150. We're trying to find the radius of the circle. So one thing we can do, we got to decide right now. The length of this arc is 150. I can't use the 150 here because I set up for the 18 angle is in there. Okay? So I think I'm going to change my mind and say that the little angle is this, which is smaller than 360, right? Even though it doesn't look very little. 18 off of 360 is 342. Now we're dealing totally in the yellow region. So the little angle here is 342 to the whole way around. The big angle is 360. Now, the little arc right here, the little arc is 150. You see, now I can use the 150 because I'm in the yellow. And what's the whole distance around? The big arc, the whole way around? I don't know. So I'm going to have to put 2 pi r there. And you can cross multiply and solve for r. Okay? So that one's a tricky one. Be careful. Your homework, the bulk of the difficult problems will be very, very much like what we just started talking about there. So good luck on those, and we'll have a good start.